Okay, so this is end of module assessment task, and we are on for Unit 5 Geometry, and we're on number 3. So this problem has a couple parts to it. First part is it has a rectangular container that has a length of 30, a width of 20, and a height of 24. And it's saying that it's filled with water to a depth of 15 centimeters. When an additional 6.5 liters of water are poured into the container, some water overflows. How many liters of water overflow the container? Okay, so let's do a picture of our container. So we're going to do, hold on a second, let's do a picture of our container. So we have a nice container. Let's see. That's much better than the one I drew a minute ago. We're going to just do that. Okay. And it says the length is 30. Okay, sorry. One second. And our width is 20. And our height is 24. Okay. So length times width times height equals our volume. So we have a length of 30 times a width of 20 times a height of 24. So I'm going to do is I'm going to thank you. Stop. Sorry. I'm back. Okay. Sorry about that. So let's do 30 times 24 first. And I'm going to do 30 times 24 there. Now I'm just going to do 3 times 24, and then I'm going to just add a 0. So 3 times 4 is 12, and 3 times 2 is 6, 7, and I'm going to add a 0 right there. Okay, 720. Okay, and then we're going to do 720 times 20. We have to do 20 more. And again, we can do that same thing. 2 times 0, 2 times 2, 2 times 7 is 14, and 0. And our final is 14,400 centimeters cubed. And since centimeters cubed is equal to a milliliters, we can just go ahead and say that's 14,400 milliliters. Okay. And let me erase that part. Okay. Now it says we're gonna fill this container up to only 15 centimeters. So let's go ahead and we need to change to 24. So we're gonna subtract this new amount. So I'm running out of room. So can I erase? I'm gonna erase. Go ahead. I'm gonna erase this up here. Okay. So I have some room to do some work. And I'm going to change to the amount of water we're going to add, and I'm going to get rid of the 24. So the amount of water we're going to add goes up to 15. So we're going to add up to 15 as the new height. So we're going to go ahead and we're going to add this much water to our container, that much water. Okay. So I'm going to do that, and I'm going to put a 15 in there. Okay. All right. So this time, let's do 2 times 15 is 30 plus 0, that's 300. So it's going to be 330 times 300. Okay. All right. Because I did 20 times 15 right there. 2 times 15 was 30 plus 0 is 300. So now I'm going to multiply 30 times 300, and that's going to be 3 times 3 is 9. So I'm going to put this down here, minus 3 times 3 is 9, plus 3 zeros. So that's how much water I'm about to add, and I'm going to subtract it to the total amount, okay? And the reason I'm doing this is I'm subtracting the amount of water I'm adding so I know how much room I have left in the container or in the rectangular container. So let's do that. So 9,000, take it away from 14,400. And I know 9,000 is only 1,000 from 10,000. And I can do this. I could do this if I want. Here, we can just go ahead and do it up here. Let's just do it. Why not practice our math, our subtraction, Good time to practice as any. I know some people are going to pull out a calculator, but I like to do it the old-fashioned way. And 0, 0, 0, and it's going to be 0, 0, 0, or 4, 4. And we'll take 9 away from 14, and we get 5. So our answer is 5,400 milliliters of space left. Now, it says we're going to add another 6.5 liters. I'm going to convert 6.5 liters into milliliters, so you have it. So I know that 1 liter is worth 1,000 milliliters. So 6.5 times 1,000 will be the amount of milliliters you get with 6.5 liters. So if you remember before, so let me erase some more stuff here so we have room to work. Okay, you're following me? Okay, I am erasing all this math right here. Okay. All right, we're good. All right, 6.5. Now, if you remember in math, what we did was we just moved the decimal point. Now, when you're multiplying by 1,000, you move the decimal to the right, one place value for every 0. If it's a power of 10. So in this case, we have 6.5. Okay, so hold on. Here we go, 6.5. And what I'm going to do is I'm going to move my decimal over 1. There's 1 0, 2 zeros, 3 zeros. So my new answer will be, let's put 2 zeros in there for empty spaces, 6,500 milliliters. Now that's how much water you're adding, 6,500 milliliters. And I'm going to, I only have room for 5,400 milliliters more. So what I'm going to do is I'm going to subtract the 5,400 milliliters. That's the amount of room I have left in the container. And I'm going to find out how much water overflows from our container. Okay. So let's go ahead and do that. Let's do 6,500. Let's go. I'm going to go ahead and erase this one more time. I'm going to erase all this stuff. And I am going to take away 5,400. I'm going to go ahead and subtract that from 5,000. Okay, hold on. 5,400. And I'm going to take it away. Okay. And I get 0, 0, 1, and 1. So 1,100 milliliters is how much water is going to overflow. Okay. That had a lot of parts to this problem. So 1,100, okay, milliliters. Now this is not the only way to do this problem, and you could write your answer in liters as well if you would like. It does say how many liters of water overflow. Okay, so let's convert this to liters. If we divide by 1,000, because if we divide by 1,000, we can do the reverse. We move the decimal over 3 spots, so the decimal always goes at the end. And we move the decimal over 1, 2, 3. And our final answer will be, okay, hold on. Our final answer will be 1.1 liters. Okay, and that's 1.1 liters, and that's your final answer. So 1,100 milliliters is 1.1 liters. Okay, that is number 3. All right, I'm going to clear everything. Hold on a second. I just lost all my tools. Okay. Okay, sorry about that. Oh, I'm gonna do Control A Alt. Okay, there we go. All right, so let's go ahead and move on to number 4. That problem took a while. Jim says that a 2.5 inch by 3.5 inch rectangle has a section that is 2 inches and 3 inches, and a section that is 1/2 inch and 1/4 inches. That means the total area is just the sum of these smaller areas of 6 1/8 inch squared. Why is Jim incorrect? Okay, so let's find out. Okay, sorry. So let's draw what he's talking about. So he's got a rectangle. Okay, let's find out. And what he did was he said there's a distance of 2.5. Okay, so 2.5 right here. And then we have a distance right here of 3 1/4. Okay. Now, or 3 1/4. Sorry about that. Okay, so we have 2.5 and 3. Now, what he does is he cuts this section off. And I'm just going to draw little dots going across here. Okay. And that is 1/2 inch. Okay. That's what he does. So that distance is 1/2 inch. And then he has this as 2 inches. So he basically just he splits up that, and I might as well just draw a straight line. Okay, so he splits off this rectangle to a 1/2 inch and a 2 inch rectangle. Okay. Now over here, he does the same thing. He cuts off, he draws a line down here. And let me go ahead and I want to just erase this because it looks bad. And he does this 3 inches down here. And this section right here is a 1/4 inch. Okay. So what he does is he multiplies 2 times 3, and he gets 6. Okay, so let's do that. So 2 times 3 is 6. That's the length times width. We're doing area right now, okay? So that's 6. And I agree with that. That's okay. So that's 6 inches squared. Because we did length times width right here. The length or the width is 2 and the length is 3. Okay, 2 times 3. Now he's doing up here, this area right here. I'm going to scribble here, sorry. And I'm going to just color it in, why not? And we got 1/2 times a 1/4. Now the problem is that he can't multiply 1/2 times 1/4 because even though this distance right here, up and down right here, is 1/2. Sorry. I'm going to just erase this. Even though this section, this is 1/2 wide, right? From here to here. It's not a 1/4 inch wide or thick or length, sorry. It is 3. It has a length of 3 1/4. Okay. So that's not going to work. So you need to really do, he has to multiply 4 different areas to do this problem, okay? If he wants to do it that way. So first of all, this area, I'm going to try to do this right there. This whole area is 1/2 times 3. Okay, it's 1/2 wide times 3 length. Okay, you can see the 3 below, and then you follow it up, it's 3. So even though this section right here is 6, this is 6 right there, you have to add that to 3 times 1/2. Okay, so let's do that. Let me get rid of this for a second. Okay, so this is 1/4 wide right there. So do I have to solve this problem? Use the area model, explain your thinking, then give the correct area. Okay, so let's do this. You have to find 1/2, so you'd have to do 1/2 times 3 to do that section. Then you would also have to do 1/4 times 1/2, 1/4 times 1/2. Okay. And that section is going to be right here, the one I'm coloring right there, that little tiny box. And then there would be another section down over here, right there, this section, and that's going to be 1/4 times 2. So that would be 1/4 times 2. And after you added all those areas, you still have to add in the 6. Don't forget the 6. So that's a lot of work. That's multiplying, doing 4 different multiplication problems and then adding them together, right? Okay, so why don't we do this a much easier way, and we just do 2 multiplication problems, and that's it, okay? So I'm going to go ahead and do it our old-fashioned way, okay? Okay, so let's go ahead and do this. I'm going to erase all that, okay? And I'm going to erase, you know what, let's just do Control or Alt-Z. There we go. That's much easier. So I'm going to just do this easier. Let's just draw a rectangle, okay? And we have 2.5 over here. That's 2.5 wide, and 3.5, 3 1/4 wide, or length on the bottom, okay? Although that looks like a square, it should be a rectangle, sorry. So here we go. We're going to do 2.5. Now, first thing, 2.5 times 3 1/4. Now, the first thing I'm going to do is change both of these mixed numbers into improper fractions. So let's do that. So as you remember, 2 times 2 plus 1. 2 times 2 is 4, plus 1 is 5 over 2. Okay, remember how to do this. And multiply it by 3 times 4 plus 1. Okay, so 3 times 4 is 12, plus 1 is 13. 13 over 4, okay? Now, as you remember, we can multiply them straight across. So multiply those two and multiply these two. So 5 times 13, 5 times 12 is 60. I know that in my head. So 5 times 13 would be one more, which is 65. And on the bottom, we have 4 times 2 is 8. Okay. And if we want to convert this back into a mixed number, this is going to be 8 times 8. I know that 8 times 8 is 64. So 8, and then there's 1 left over, and that's 1/8. So you can even do the math if you wanted to do that. 8 into 64, 65. 8 goes into 65. 8 times 8 is 64. And we subtract, you get 1 left over, and the 1 goes back over the 8. Okay. All right, that was 8. Oh, by the way, don't forget to do your labels. That's going to be inches squared. And make sure you explain when you're saying, why is Jim incorrect? He's incorrect because he's only multiplying 1/2 and 1/4 when he should have been doing 1/2 needs to be multiplied by the 3 and the 1/4, not just the 1/4. Okay. All right. So we're going to erase this. Let's go ahead and erase this, and we're going to go on to the last one, which is, let's see, our last one is Miguel. Miguel and Jackie build towers out of craft sticks. Miguel's tower had a 4-inch square base. Jackie's tower had a 6-inch square base. If Miguel's tower had a volume of 128 cubic inches and Jackie had a volume of 288 cubic inches. Whose tower is taller? Okay. Well, you can't just say whose tower is taller by the base, because even though Jackie has more area, he also has a wired. Hold on one second. Okay, sorry about that. I'm back. So let's go ahead and draw some stuff here. So first of all, Miguel's tower had a 4-inch base. So 4-inch base is, these are squares. So let's draw this out. So he has a 4-inch base. So that means it's 4 by 4. So 4 times 4, and that would be his base. Okay, so 4 times 4 is 16. Squared, sorry. And then he has some height to his tower. Now, we don't know what the height is, but I do have another clue. I know that 16 times... Okay, again, Mr. Nelson apologizes. Sorry, everybody. So we have 16. Now, 16 times a height. We don't know what the height is, but we multiply it by some mystery number, and it gives us 128. Okay, so 16 times some number will give us 128. Now, you can undo this by dividing 16 into 128. So let's do that. 16 into 128. Okay. And I'll let you cheat. You could use a calculator if you'd like, or you can pretend that it's 20s. Okay. So I'm sorry. So let's see. So 16. Let's say that 16 is close to 20. So we'll do 20 times 5. I know is 100. 20 times 6. Let's try 20 times 7 or 20 times 8. 8 times 6. Let's try 8. So 8. I'm going to try 8. 8 times 6 is 48. And that's why I did that, because I know that 8 times 6. And I'll put a 4 there. And 8 times 1 is 8. Plus 4 is 9, 10, 11, 12. So 128. And we're at 0. So 8. So this would have to be 8 inches. So Miguel's tower is 8 inches tall. Yeah? So 8 inches tall. Now, we're going to find out how tall Jackie's tower is as well. So let's find out how tall Jackie's tower is, okay? All right, here we go. I'm going to erase this. 8. Okay. So let's rewrite this. Hey, okay, sorry about that. So let's go ahead and draw it. And we have a tower that's 4 by 4. So it's 4 inches, 4 inches. And we found that his tower is 8 inches tall. Okay. So 4 times 4 is 16, and 16 times 8 was 128. cubic inches. Now let's see Jackie's tower. Jackie has a tower with a base that is bigger. It is 6 by 6. Okay. And she has a height. We don't know what her height of her tower is. But if we did all the calculations, it would be 36. 6 times 6 is 36 times some height. And that would give us 288 cubic inches. Okay. Cubic inches. Or inches cubed, however you want to write it. Okay. All right. So to do this, you have to divide 36 into 288. 288. Okay. So 288. So 36 is really close to 40. So I'm going to use 40. And we'll say 40. How many 4s go into 28? Okay. Or how many, you could do how many 3s go into 28, but I'm sure it will go over. So if we did 3 times 9, we get 27. If we did 4 times 7, we get 28. So if I used 3, I would have to go with 9. And if I used 4, I would go with 7. So let's go in the middle. Let's say 8. Okay. So 8. Let's try that out. 8 times 6 is, so I'm writing it in the wrong spot. Okay. Okay. So let's try 8. 8 times 6 is 48. Okay. Put a 4 there. And 8 times 3 is 24. Plus 4 is 28. Oh my gosh. Look at that. The tower is, their towers are the same height. Okay. So whose tower was taller? We just found that both towers are 8 inches. So 8 inches is the height of the tower on both of them. 8 inches. See, 8 inches and 8 inches. So they both have a tower. So even though she had a larger volume, or so how much space inside of her tower, they both had an 8-inch tall tower because because she had a larger volume and he had a smaller volume, but they had the same height. So you can have 2 different objects with the same height, but they have a different volume. Kind of like if you want to think about it, you could have 2 different buildings the same height, but one building is smaller than the other building. It makes sense. Okay. And you can explain that as well. All right. Let's go ahead and erase everything. Okay. And we're going to scroll down. And let's check something out. I believe this is the last part of the assessment. And I know this has been going on for a while. So why don't we... I'm going to have to edit this too, I think, a little bit. So let's go ahead and look. We have, read the statement, circle true or false. Explain your choice for using words or pictures. So all parallelograms are quadrilaterals. So a quadrilateral has 4 sides, and all parallelograms have 4 sides. So I'll say true. Okay. So 4 sides, that's all the requirement is, 4-sided. In fact, there are more requirements for parallelograms than quadrilaterals. 4 sides, and both of them have 4 sides. Now, not all quadrilaterals could be parallelograms, but parallelograms will all be quadrilaterals. They all have 4 sides. True. All squares are rhombuses. No. And let's see. Well, actually, yes. Okay, so square. So all squares are rhombuses. A rhombus just has to have 4 equal sides. That's all it needs. In fact, most rhombuses look like this. They have a slanted, and they look like a diamond. They're kind of like a tilted over square. But all squares are classified as rhombuses. A rhombus has to have 4 equal sides. That's it. All squares have 4 equal sides. True. Yep, it's true again. Okay, can't fool me. Okay. Squares are rhombuses, but not rectangles. All squares can be rectangles. That's true. So if that statement, but not rectangles, no, all squares should be rectangles. Yep. So we're gonna have to say that's false because squares are rhombuses, but they are rectangles. Squares can be rectangles. True. Okay, so I mean, since a square has to have 4 equal sides, a rectangle has to have 4 sides where the opposite sides are equal, and that's always going to be true with a square, always. Okay. The opposite angles in a parallelogram have the same measure. That's also true, always. Okay. And they have to be because a parallelogram has opposite sides have to be the same length, and they have to be parallel. They have to be parallel too. So those are all equal. Okay. And their opposite corners, this one, like that one, and that one would also be equal as well. Okay. So let me do that again. So this side, that angle and that angle are also equal always. Okay. Okay, I'm just going to control Z. Okay, and the last one is because the angles in a rectangle are 90 degrees, it is not a parallelogram. That is false. Parallelogram just has to have opposite sides are parallel. A rectangle always has opposite sides parallel. So a rectangle is always a parallelogram. Okay. So let's go ahead and control Alt Z this, and we're going to get rid of that, and then we'll roll it up. So we are on letter E. We only have F and G, and we're done. Okay. Wow, we're in the home stretch. So letter F, the sum of the angle measures of any trapezoid is greater than the sum of the angle measures of any parallelogram. That's going to be false. The angle measures in both a parallelogram and a trapezoid are 360 degrees. Always. So they're all 360 degrees, so they are always equal. So that will be a false. And what they're talking about is, so you know, is, okay, if we took there's a parallelogram, let's do that, and here's a trapezoid, okay. Oh, wait, hold on a second. No, it's true. That's true. So all these angles, if I added up all the angles in here, so all these angles, they're going to equal 360 degrees. And if you added up all these angles, and they're all going, if you added them all together, those will also add up to 360 degrees. So, yeah, they're always going to be equal. All right, here we go. The following figure is a parallelogram. It appears to be, let's see this. So if I add up, let's see. So if you add up the two angles that are opposite of each other, they have to equal 180 degrees if it's a true parallelogram. So these two angles must be added, and they must be, so let's add them up. So they must equal 180 degrees. Let's see if that's true. Okay. So 60 plus 10 is 70. So it's 175 and degrees, and let's see, is it equal to 180? And the answer is no, they're not equal. So, and since they're not equal, this statement is false. It is not a parallelogram. Although it looks like one, it's really close. It's not. I mean, these sides look like they're parallel, but they're off. They're off by just a little bit. One's pointed inward. So that's 60. If that 60 was a 65, so slightly outwards, you would have a parallelogram. So thanks for watching my video. I'm so sorry it's so long. I am going to go back and try to edit there. I know there's a lot of dogs barking. Ironically, I'm done and my dogs are quiet. And next time I'll just go hide somewhere. So hopefully you can follow through and it's not too long to follow. So thank you and have a great day.